specifically, we looked at, picking up some geochemical data from a spreadsheet and then plotting them up. Now, again, this is a very important part. And like I said last time, the plots that you generate are essentially publication quality plots, particularly the PDFs. And we also discussed how we can save the plots and so on and so forth. Now, what I want to go over a little more is looking into logical or conditional programs, and then go into a little bit of data containers and then functions. And if time permits, I have two libraries that I want to show. One is called PyGMT, which is used all over the world by geophysicists and geologists to make some beautiful maps and for publication. And then again, if we have time, I want to show a quick demonstration of how to use GEMPy using one of their examples. We can kind of we would have then touched upon some of the key aspects that we will try to cover. Obviously, we are going to go into more details during the main course. I again would kindly request you to hold your questions until the end of this session. And then, as Mr. Nikhil said, please send them your questions through WhatsApp or various medias through which you can contact with PEA. Okay. So without further ado, let us jump in and go on working on what we want to discuss. Now, in any programming, what we have done until now is called procedural programming. That's just a fancy word for saying that we feed the computer an equation and a bunch of data, and the computer just performs that. Okay, that's all nice and good, but typically in scientific work, we have some limits of, I want my calculation to be performed if and only if this particular condition is met, or I want to repeat a particular function given a particular condition or up to a particular condition, and so on and so forth. There are many different combinations that you want to do. And Python, being a very user-friendly program, allows you to do that as if you are talking to another human being. Okay. So what I would like to start with is some basic conditions. And again, I'll show you an example using a geological example. Okay. So let us look at conditional programming. Okay. Now, what does this include? This essentially includes the following. The following is if. This is sort of a triplet where you can provide a particular condition, and then if that is met, then a particular task is fulfilled. If that task, if the if condition is not met, you can have other elifs. And when you have exhausted all your conditions, then you have an else section. So let us see if if a particular temperature is greater than 100 or less than 100. Again, I'm showing very simple examples for people who have no experience with this. So for example, if I say, let us say I am going to input a temperature, and I am going to say int input a temperature. Okay. Now then I'd say that if, so the moment I use the keyword if, you will get a Python recognizing that you have used a command that is that it understands. So it says if temp is less than 100, or if temperature is less than, yes, is less than 100 or less than equal to 100, no, less than 100, that is correct. You can print, then water will not boil. Now, then, I mean, what if it's the other way around? You can say then else print water will boil. Now, so let us run this piece of code and see what happens. So you mean, give it some time. Now, immediately Python asks you the question, enter a temperature. Let's say I put in 500 and then I hit enter, and it immediately goes through the code and then says water will boil. Again, in the main course, I will walk you through how Python reads these kinds of temperatures. Okay. Now, you don't have to set it up as like this, as less than. There are other options. So the condition parameters that you can use, so the conditions that you can use go from when you are comparing two variables with each other, or two things with each other, a variable or a number or whatever, you use the equal, double equal sign. And then obviously you have your not equal to, that is your not equal to symbol. And then you have your greater than, less than, greater than, equal to, less than, equal to. And there are two logical ones. One is called and another one is called or. Okay. Now, let us do a particular problem where we use this and or thing together. So let us make that let us make this program a little more complicated. Okay, so let us say that we are not satisfied with just saying if temperature is less than 100. Okay, so we want to devise the program in such a manner so that I can say if water will freeze, water will boil, and water will will evaporate at high rate. Okay, so again, what we'll do is we are going to say temp1 equals. I apologize for my throat. I have a little cough and cold. Temperature. Then you can say if temperature 1 is less than, or rather is greater than equal to 365 Kelvin would be what in degrees centigrade? 365 is 17 minus 347 Kelvin. Quickly, if I use my calculator, minus or Kelvin is temperature plus 340. that is about minus 620. 620. Temperature 1 is less than equal to 0. Then let us say then if temperature 1 is greater than, let's make this greater than this, is greater than 0 and temperature 1 is less than equal to 100. This is actually less than 100. Is water. Then you can say if temperature 1 equals 100, water is boiling. Okay. Now, to you, this might be in the beginning really trivial, but imagine if you have a rock melting experiment going on for looking at geochemistry, and you want to see what temperature certain rocks have melted, and you have some previous data or that you have collected from journal articles, and you are actually trying to compare your temperatures for a given rock composition with somebody else's melting temperature experiments for the same composition. You can then develop a little piece of code where you can compare your temperatures, not only compare your temperatures, then essentially calculate the differences in those temperatures that you are finding. And then if they are significantly different, you can look into what is the difference between experimental procedures, or are the compositions exactly the same, different as you had thought. Okay. So these are some of the issues you can solve with programs like this, particularly when you have the capability to lay out your logical arguments in this. In fact, the most interesting part about all programming is this logical part. Most of the time, you know the mathematical expression you want to use, and so it's very easy to just plug it in. The challenging part is setting up this logic as to, you know, the order of operations I am going to set so that it gives you the actual result. Now, this is a very good time to give you a little nugget of information that often programmers tend to forget. And, you know, this is a very good piece of advice that I received while I was learning as well. And that is, just because your program has worked and it has given you a number or given you a solution does not mean that the code is correct, or rather, sorry, it does not mean that the science is correct. And this stems from the fact it is very easy to write a grammatically correct program which does either incorrect calculation or misuses the formula or the logic. Okay, that is very easily done. Okay, so oftentimes when we start programming in a new language, the program works and say, oh, excellent, my the signs and the numbers that are coming out is also correct. Please keep your eyes out for these kinds of pitfalls. Okay, you must compare some standard values that is shown in the computer program result with your own handmade calculation. So uh, at least once you have to test some standard values, obviously related to that experiment. Okay. Now let us run this piece of code, and then we say enter temperature. So I am going to give minus 150. Okay. And I say get water will be frozen. Now look at the interesting part. Once the condition is met, it immediately exits the entire if loop. So it doesn't go into any of these elif, else. Another piece of information to see is that when I wrote the if segment, okay, so the if logic part is given over here. Okay. The end of logic part is given by this colon, and then there is some space. In fact, actually this is 4 spaces. This is called an indentation, and this is how Python keeps track of what is in what if block. Okay. All logical statements have their own block pertaining to the calculation you have given if that condition is met. Okay, so this print statement is in this if block. That is why the elif is outside this if block. Okay, but at the same level of this if. Now it is entirely possible for you to write a nested if comment. Nested if program, which means you have an if within an if, and then the blocks or indentations will have to be adjusted accordingly. Now, during the course, I don't want to take up too much time on that one here, but in the course, we will show you using another program how writing standalone program becomes easier, because that particular program actually gives you a line that tells you the indentation block for a particular if statement. All right, so moving on. The next thing that we are interested in is loops. And for loops, we have 2 commands. We have the for loop and the while loop. The difference between the for loop and while loop is while loop acts with a condition. For loop doesn't necessarily act with a logical condition. It works with numbers and number limits. So for example, if I want to generate some numbers, I can just do some repetitive calculation. I can say, so let's do one very quickly. I can say that for m in range 100, I can say a temp equals temp plus 73. And then I can say print underscore a. Now, let's say this is an expression that you are interested in, and you want to calculate the conversion for 200 from 0 to 200. Okay. Now, if I run this particular piece of code, this temp is called an iterator, means it keeps track of how many times it has gone through this particular loop. And this range n or range, the argument tells, gives the the for loop the iteration it needs. So once it goes through, it changes and it increments temp from 0 to 1, 1 to 2, so on and so forth. Now you don't have to start at 0. So the format for this is 0, 200, 1. That means the default is 0. Then whatever endpoint you give, comma, then the step value is 1. Okay. Now, if I run this code, you will see I get every degree, I get a different number. Okay. Now, what if I say this is 100 to 200? If I run this code, I get only 100 numbers. Okay. But the interesting part is it never reaches 200, because if I say print temperature, comma, that, you will see to the left, it never reached 200. It reaches 199. Again, this is a little quirk of Python. You have to give an extra number. And again, we'll go into the details of that during the main course. Now, I can also change the step value from 1 to 5. And then you can see the step values are changing every 5 degrees centigrade, and accordingly, the changes are happening here as well. Okay. Now, this is one way of doing it. I could do the same problem using the while loop. And here I will say temp equals 0. Oops, sorry. While temp less than 201. Again, for as well, note how there is an indent. That means for the for part, there is a block, and that block will be executed for the condition or these the numeric values that are provided. Okay. Now, for a beginner, the for loop is very enticing and very helpful. Typically, beginners try to avoid the while loop because it has a couple of tricks. One is that you have to initialize that, then you have to provide a condition, then you have to. So I'll just copy this part. And then the key part is you have to increment the iterator. Otherwise, you are going to go into a permanent loop, and your computer won't crash, but you will lose a lot of computational time. Okay. Now, if we execute this code, I get the same result. Okay. Again, here I have this has plotted all 200 data points. Okay. Now I can do the same thing. Instead of this, if I do every 10, temp is equal to temp plus 10, you will see that I can do this. So what you can do with for, you can do with while, but in while, the number of steps required is a little more. Okay. But one of the things about while is you can put an entire condition, you know, temperature is less than is greater than 100 but less than 200. So you can put conditions like that over here, and then it will do it. These kinds of conditions are very difficult to put into for loop. Okay. Moving on, we will look at some data containers. As far as data containers are concerned, there are 4 types of data containers: lists, dictionaries, tuple, and set. Okay. And Python uses very specialized parenthesis system to recognize them. lists are recognized by their square brackets. Dictionaries are recognized by their curly brackets. Tuple is recognized by general parenthesis. Set is also recognized by general parenthesis. Today, I will only talk about lists. The other ones, up till tuple, we will discuss in the course. Again, we are not going to try to cover every aspect of Python. First of all, that is not possible. Nobody knows everything about Python. Number two, we are focusing towards geosciences. So we have to, use what we need to use. Okay. I mean, we all use a dictionary, like in actually a dictionary, but hardly any of us memorize the entire dictionary, unless you are you have photographic memory and are interested in that kind of a thing. Okay. So list is the original way to store data in Python. So let's say I keep a list, or I call it a rock list. Okay. And a rock list can have all kinds of data types involved in it. So I could put in the word granite, then the number 68. Then I can also put in another list inside this that contains, some mathematical values, and then, and so on and so forth. Okay. Now, how do we access this material? And that is called indexing of a list. So the master list, which is the outermost brackets, that contains the master list. And the master list contains three elements: granite, the number 68, and this list in itself. Okay. So if I want to access, let's say, the number 68, I would say list, then 1. Now you would say, why 1? Well, the reason is, again, Python's index list starts from 0. So granite has an index number of 0, 68 has an index number of 1, and this whole thing has an index number of 2. So if I say that, yes, so see, it tells you 68. Now, what if I want to access basalt here? So then I would say list. Then I have to say this index number, which is 0, 1, 2. Oops, sorry. 2. And then inside 2, I have to, inside 2, I have to say this is 0, this is 1. Okay. So this is like a coordinate system. And again, we'll go through this in detail in the actual course. So there you go. And we will use these kinds of things a lot while writing main big programs. Okay. Now, let me switch environments, and I want to show you a plotting system called PyGMT, which is very interesting and can do some really interesting stuff. So let me try. I hope this works. I've never tried to do it this way, but let's see. So please give me a second. It's trying to switch environments. So it takes a little bit of time. While it is doing that, let us continue looking at some other examples. So let us look at another concept in Python called functions. So function involves writing a piece of code inside Python that can be called repeatedly. So it's a function that can be repeatedly called. So how we write a function is, first we create a definition. So let's say I type the definition square and say that I pass an argument through it. And then I write some comments to kind of make sure I understand what is it that I am trying to do. Calculate square. Now, so let's say I type y equals a times a, and then I say return y. And then in the so this is my function that has been defined. And then I write a program called num equals input a number. Then I say square. There is a lot of variables flying around and it can be very confusing. The idea is very straightforward. The idea is I am going to input a number, then ask Python to execute this function that I had written called square, except the argument I am going to pass is num, which is the user inputted value. Now, once Python receives this, it goes back to this definition, which it has read into its memory, and tries to solve it. And it says, okay, I have this square and that square. I have one argument coming in that happens to be num. So num becomes a, and then y equals a into a. Now, what is a? Num, num. Okay, so the num into num, you get something. And then this return call returns the value of y back to where it was called. And that is the value you have. The Python shows you that value. So if I say 9, I should get 81. Now, there is a difference between printing. So if I put a print in the function itself, okay, and then I write this code and put that, you would get 81 twice because it prints it from within the function and then outside the function. Okay. So you can do both of that. Okay, let's see if my thing is ready. I believe it is ready. And let me try if I can get this running over here. Let me see. Let me try that. Import. Okay. So I will have to quickly launch another Jupyter notebook, so which I will do immediately, and it should be able to then execute those commands. It's taking a bit of time. Let us see. Yeah, this is the thing, but I mean, this would be really nice if this all works out. Otherwise, we'll continue. Oh, okay, okay, it's opening. It's opening. Excellent, excellent. Okay, excellent. So I will just side. So a few more seconds, and it should we should be ready to go. I had to close the initial Jupyter notebook for this to come into play. Okay. To course, I'm going to create a new one, and once it opens, I am ready to go. And don't worry, I'll show you how to install this, how to work with this. I'll walk you through all the steps. And I'll tell you why I had to create another environment, what an environment means, all of that will be done for you. So please don't worry. Okay, the kernel is starting. So in the meantime, I'll do some imports. Import this. GFT. Say so essentially what I am doing is I'm asking the computer to put it in its memory two libraries, the first being OS, which is the operating system library, so that we can access any folder in our computer easily. And then obviously PyGMT, which is the Pythonic wrapper of the well-known program generic mapping tools. If any of you have worked with seismology or geophysics, I'm sure you know this like the back of your hand. In fact, I think you would know better than me. But you know, I did some coding on GMT, and I think this is something geologists should also know. Okay. So if I execute this, hopefully this will accept it, and then we can go ahead and show you some stuff. So the star is hanging on, so that means it is running stuff. So thankfully, hopefully it has found that, and then I will go ahead and show you some code. So it is reading up all the material for PyGMT. So there are about 60 to 70 commands. This kind of trying to put it in its memory. So it takes a little bit of time. So I'm going to say this is session 2 GMT. Okay, so this has been successfully run. Operating system is in, PyGMT is in. It has given me all this information about the stuff. So we are all good. Okay, so now what I'm going to do is I'm going to create a very simple plot to see if things are all okay inside. Now, the base of GMT is called a figure. So what we will do is create a ask PyGMT to generate a figure in the background. Okay, and then we are going to plot a global map with the coastlines of different countries. So I'm going to say fig.coast. Again, in the course we will go through details. I am not going to be able to go through all of that here. Then we have region equals G. Then I'm going to say frame is true. Lines. See, it's not shoreline, shorelines. and then I'm going to say fig dot show. So in this one, we have to show the show dot inline. If I execute that code, okay, and there you have a map with the global locations over here. Okay. Now, what if I take the same code and I want to see this in another manner? So I am going to say projection equals W50. Then frame is true. Shorelines equal to, actually, this one I'll say base map. Base map. So projection and frame is fine. I'll just take the shorelines and take that from the PS coast. Dot coast. And if I execute this, I get a plot like that. Now, there is a lot of things you can do to kind of generate different things. You can add color and this and that. So all of that is very much possible. Okay. In fact, let us try to put that thing there. Let's say land equals green, water, sky blue. So let us run this code. There you go. Okay. I mean, you can see just by writing a few lines of code and, you know, by knowing what those switches do. So there is an initial learning curve in this kind of a thing. But once you get the hang of it, you can generate. Again, the maps that I am generating are all publication quality maps. All right. So none of this is, bad quality maps. You can actually take this and put it into a photo editor of any sort and then do all kinds of editing, or just put it in your paper directly if you have what you need done. Okay. Now, everybody is interested in looking at data and data plotting. Okay, so let us plot some earthquake data. Okay, and so let us play with some earthquake data stuff. Now, GMT comes with some preloaded data, so I'll use that preloaded data, but doesn't have to be. You can pull out data of your own. That is not a problem. So let us create a data plot. So data equals GMT dot datasets dot road sample data. This one, right. This one is, what is the name of the data? It's called, I think, Japan. Yes. Name equals Japan quakes. Japan quakes. Okay. Now, what I'm going to do, I am going to create a projection region. Okay. So then what I'm going to do is say region equals, and I'm going to give it a list. And in the list, I am going to write data dot latitude, longitude dot mean -1 data dot plus 1, so that the border of the image is a little, there is a little buffer between the plot and the border of the area. Latitude dot in 1. You can space, yes, and data dot max. Okay, so now I have set my region, and now I can then see what the data looks like. So I can say print region, and I will also say print data dot. So if I execute this code, I get attribute error. Oh, data sets. I misspelled it. Okay, so this is what the data set looks like. So the region, so this region that I just defined, that is this. Okay, and what did I type here? Oh, I should have typed latitude. Because you see, the way I caught my mistake was 150.89 and 150.89. That should not be the case. Japan is not, there is no latitude called 150.89. Okay, now this is correct. 131, 150, 34, 50. Okay. And then the data contains year, month, day, latitude, longitude, depth in kilometers and magnitude. So that is how the data is stored. That's fine. Now I want to plot this data. So again, I have to create a figure called igmt dot figure. Then I'm going to create a fig dot base map, and then the region is going to be region that we have already defined up there. The projection is going to be a marketer projection, and then the width of the map will be 15 centimeter, because because I want it that way. You could choose to have another length, that is fine. Frame was true. Then I go in, and then I'm going to draw the coastlines. Fig dot coast and equals, let's say, that. Then you will make water equals sky blue. Then I will have fig dot plot. So fig dot plot does an x. This is called plot xy for people who use GMT in its original form, or PSXY, if you recall that. So this one is data dot and this y is data dot latitude. Then I put in a style of equals C 0. See. C 0 point. So what I'm saying in style is what is the shape of the symbol. The symbol is going to be a circular symbol, and the radius of that circle will be 0.3 centimeter. So color equal to white. So the color inside the circle is going to be white, and the outer border is going to be black. Oh, sorry. I should have used this quotation closes here. Pen is black. And then I am going to say fig dot show. I have to close this bracket. Oh, sorry. Too many brackets, I think. Yes, too many brackets. So, fig. Okay, so again, if I execute this code, you will see this beautiful picture of Japan show up, and with the earthquake data. Now, it is entirely possible for you to play around with and make the symbol as a function of the magnitude. Okay, so let me make some quick changes and let me show you how we can play around with that. So we are going to make the style CC, and we are going to add a command called size equal to 0.02, and you can play around with these numbers as much as you want. 2 to the power data dot magnitude. Now, if I say this, you will see that the earthquakes that have been plotted are as per their magnitude. So the bigger the circle, bigger the magnitude. Now, this is fine, but if it had color, then it would be very nice, right? So let us do that. Now, for that, we have to play around with some more information. Okay, so I will essentially copy this entire code down here, and I promise I'll let you leave after this. That is done. That is done. Post is done. Okay. Now, right after this, we are going to create a color map. So we are going to create a CPT. Map. So these terms are already there in the system, and I'll show those to you when we get to that. Data is data dot depth kilometer dot data dot depth underscore kilometer max. So that is done. Now comes the plotting. Longitude, latitude, size. Okay. Style is CC, color is that. Now, what I want to do, the size, I want to say color is not white anymore. Color is going to be representative of the depth. So that I don't need over there like that. Depth. Sorry. kilometer. And then I'm going to say CMAP equals okay. Now after this and before the fig dot show, I have to say to plot the color bar. So the fig dot color bar, name of the color bar is equal to this one is there. This one is also there. This one also needs another. This one, I guess I will show that quotation mark. That so that this whole thing becomes that. Okay. Now, if I run this code, you will see that you get it. Uh-oh. What did I type wrong? I wrote something wrong. Okay, so I must have made a mistake somewhere while typing. So this is fine. 15C frame equals 2, true, that's fine. Black sky blue, that's fine. That's fine. Latitude, longitude, that is fine. Okay, so I think it's the order in which I wrote things that is causing the trouble. X. Equal to yes. Okay. Style CC. Okay. Black. Okay. So see, this one works. It says file not found. Okay, what file is not found? Okay, well, we have kind of gone off over time, so we'll stop here. I don't want to go through, make you wait through me going through the debugging process. There's something that I have either typed wrong that I am not catching quickly that is causing this problem. So